Hi everyone, welcome to another episode of AI for Humans. And wow, oh wow, we are at thing. It's been a very interesting journey trying to break it down so like even my 10-year-old cousin would understand. I mean, I probably haven't done justice to 10-year-olds, but I think so far so good. The anyone can from this playlist be able to get the idea of what goes on in the AI world, and we've come a long way from understanding what data is to the models. And even up until generative AI. So now we know how ChatGPT works. We know how those answers come. We know how the answers are generated. We know that there is no mega brain somewhere. It's just a very good probabilistic system. And we now know even how images are created. Now, let's go a bit deeper into what you'd actually call actual AI engineering, because it's a very big buzzword out there, but most people just use it, but they don't get the idea of it. So one of the major things in AI engineering is fine tuning. And that's actually what we're going to be discussing today because it's the very core of building AI systems. Now, you think of it, when we talk about training, it's an easy word to say, but training is not so easy in terms of the time it takes, the amount of resources that it takes, right? ChatGPT probably trained their system on, they used over $100 million to train the system. And we're not talking about something that happened in like seconds. We're talking about hours of running these machines. So imagine if for every new LLM we wanted to train, we actually needed to train on these systems like for hours, right? It will not be easy for just anybody to create a system like ChatGPT. But you see a lot of them out there today. You have the ChatGPT, you have Anthropic, you have DeepSeek, you have all of those guys. So what exactly is going on, right? Plus, how does fine-tuning help them? Now, systems like ChatGPT and Claude were actually trained like from the ground up. But early last year, a new system came up, and that system was called DeepSeek. And DeepSeek, unlike traditional system, was not trained on data the way ChatGPT was trained. They didn't use all the resources and all the time. In fact, what they did was a very, very heavy type of fine tuning, right? They used existing data, which we're going to go into like in detail through the course of this. But what exactly is fine tuning in the first place? So think of it like this, right? They say stuff like you can't teach an old dog new tricks, which is actually a very interesting saying. But in AI, old dogs can actually be taught new tricks. So what exactly is fine tuning? So let's use a diagrammatic view to look at it. So let's imagine that you have a very smart person who is a doctor. So, doctors and I know throughout this playlist I've been drawing abominations and everyone has been talking about it, but don't worry, just you get the idea. So let's imagine that this guy's name is Chad, okay, and Chad is a doctor. So, and by doctor here, we mean that Chad is a general practitioner. So general practitioners are guys who they understand the anatomy of the entire body. They can look at this part. If your ear is paining you, they can tell you who to go to. They can give you an initial diagnosis and then tell you to move on to someone else. General practitioners are not specialists, right? They just know every part of the body and know the most, the very basic parts that doesn't have to do with special cases. That's the idea. Now, why are we using Chad for this case? Let's imagine that we want to make Chad a surgeon that deals only with the brain, right? He's the surgeon that treats just brain. He specializes on brain surgery. He doesn't specialize on anything else but brain surgery. Now, think about it. Would we have to send Chad all the way back to medical school and say, okay, go back and do another maybe 5 or 7 years of medical school, and then come out and then we're not going to train you for another 3 or 4 years on surgical, right, brain surgery? I don't think that would be necessary. Why? Because Chad already has general practitioner's knowledge. He already knows about the brain, right? What we just want to do at this point in time is that we'll take him to the surgical school and we'll give him a residency. So we'll take him to the surgical school for 3 or 4 years, right? And we'll say, study just the brain. Like, we know you know everything about the body from head to toe, but just study the brain and then study the brain, focus on that skill. And that exactly is what we are calling fine-tuning. We have fine-tuned Chad to become a specialist doctor that now focuses on just the brain and not the entire body again. And I know at this point, this is probably looking like pretty weird, right? I get it. But you're going to understand what we're talking about here. Okay. So, let's start with a very simple definition where we say that fine-tuned models are simply foundation, and you understand what I mean by foundation model, right? Foundation models that are now trained on specialized data. So the foundation model, sorry, my pen is acting over here. Foundation model trained on specialized data. That is not proper writing, and this would give us a fine-tuned model. Okay. Now, what examples do we have of this for stuff like this? So remember we said that this guy, Chad, was the general practitioner. He knew at least a bit about everything, but now we just want him to know so much about something particularly and just, maybe just shut down the rest that he knows. So if you've ever used, programmers will know about what we constantly call, there's GitHub. GitHub is a place where programmers like save all of their code, right? So it's a very interesting atmosphere there. So GitHub Copilot, and GitHub Copilot was something that Microsoft built. So what exactly happens in GitHub Copilot is that we took ChatGPT, right? Like and this here is the foundation model, right? So let's call it F model. We took ChatGPT, right? ChatGPT here is a general practitioner. Interesting that GPT actually works with that. It's a general practitioner that knows about everything. It knows about code. It knows about science. It knows about math. It knows about English. It just knows about everything. And then we said, okay, look, we want ChatGPT to be an excellent coding system. In fact, we want to create a system that is so excellent at coding, like nobody in the world can beat it. That's the aim, right? So what they did, then they added the specialized data. And what is the specialized data? Now, GitHub is a place where programmers, after all the software that is written in the world, right? Many people actually go on GitHub and they put the code for their software on GitHub. This is how we wrote the software. This is how we built Netflix. Everything that we used to build Netflix, we put it on GitHub, right? GitHub just has one type of information, and that information is nothing but what you'd call code. There's no math, there's no science. I mean, ideally, there's nothing like that on GitHub, right? It exists maybe just for documentation, but the code is the main thing. You have code written in languages like Python, like Java, C++, everything you find on GitHub, right? Good. Now, so what happens next is that we move on and say, okay, good. From this point, remember our definition is that we want foundation model to work with specialized information. And so when we add these two together, we now create what we call, okay, sorry about that. We create the fine-tuned model. So this is the beauty of the fine-tuned model now. It is like the brain surgeon. It is so good at code because it has been fed, we fed it all the coding data. It's like retraining the model, right? We're giving it new data, but this time, unlike ChatGPT that we gave it data about literature, about math, about science, about economics, we are only feeding the model code. We are only feeding model that has data with code. It does not receive any other data from any other source. It does not receive data that has to do with any other thing. And another interesting thing that we do when we fine-tune the models is we kind of tell these other sources of information to shut up a bit. Just keep quiet, right? So we engineers would normally say they reduce the weights. Remember we talked about weights in models, and we say weights are the connections, right, between words, between all of those information that is fed in there. So we are like saying, okay, now we just want you, we know you have all of this, right? But just tone this down a bit, tone this down a bit, tone this down a bit, hype this up, add this to it, and become a fully coded system, right? Code, just do code. Don't do anything. You don't know math, you don't know English, you don't know. And sometimes fine-tuned models are so well fine-tuned that if you ask them a question on math, they'll tell you they don't know, right? If you ask them on English, they tell you they don't know. What we did there was that we killed the weights. It's like killing the weights. Like we just told it to shut up about this, shut up, shut up about this. Don't tell anybody anything about this. Focus on what you were specifically specialized on. So it's like the surgeon, the Chad, the brain surgeon now goes to the hospital and say, oh, Chad, someone has a leg problem. Like, oh no, I don't deal with legs, right? Take him to the person that deals with leg. Remember that Chad was a general practitioner before. He probably knows more about those legs, but he knows about the legs. But because now his focus is the brain, right? He would most likely just tell people who have leg problems to go to a doctor who solves the problem on legs, and he focuses on brain. Same thing happens here. So this model is focusing on code. It ignores all of these things, math, English, every other thing that he knows. It kills it a bit. It just we use the term. We use the term, and this could actually be very useful. We use the term freezing, right? Once again, this pen is going to be the end of me. So we use the term freezing. So we say we are freezing the weights, right? So, I mean, think of it, right? You put something in the freezer, it becomes ice block cold. You can't like move it. Okay, I'm trying to overanalyze it right now, but that's what we're doing. We're freezing the weights, right? So that's what we've done. We've frozen all the weights that we do not need, and then we've given more weights to the stuff that we need. So we froze all of these weights and we gave more weights to the stuff that we need. Now, GitHub Copilot is one of the very interesting examples, but there are actually more examples of AI systems that were fine-tuned. For example, some law firms, like very big law firms, because once again, fine-tuning is quite expensive, so it's not something that is easily done. I remember that you need code, like you need a lot of data to be able to fine-tune a model. So imagine also GPT, right? So imagine somebody taking ChatGPT right now. And remember, ChatGPT knows everything about everything. I mean, if a bit about everything or so much about everything. And we say, okay, look. And what most people do in this case is they take what we call proprietary data, right? So if you work in a company, like you work in a software company, we have proprietary data, right? This kind of data is data that we only use in-house. Nobody outside knows about this data. Don't forget that we talked about the data in the data episode that ChatGPT was trained on data all over the internet. It was scraping data from everywhere. But there are some levels of data that ChatGPT doesn't have access to. This data is called proprietary data, and this data is saved in, the database or the data warehouse of your company. Nobody else can have access to this data, right? This data is saved, locked in-house, and this data holds intelligence about how your company works, right? So what we do is that you would now take that data, this is now your specialized data, you will add it to ChatGPT's originally existing data, right? And then freeze the weights, and here I will make sense of why freezing the weights is important. Freeze the weights, and then you would then break it out, and you would have a fine-tuned model. Okay, you would have a fine-tuned model. Now, why is freezing the weights important here? Imagine if you had a law firm, like you work in a law firm and you have your own model, in-house model. You have trained it on your data, and then somebody comes and asks the model that's supposed to be for a law firm and asks a question like, I want to know how to cook rice. And imagine the GPT system answering that question, right? It doesn't make sense for it to answer. It's not supposed to answer questions like that. So freezing the weights can actually help you to be able to it's like forget all that nonsense that you know and focus on the stuff that we're training you to know. Freezing the weights is not exactly the only thing that does that. There's something called instructions, which I wouldn't really want to go into, but it will be in a later episode. So instructions are a way to tell the model what to do and what not to do. But again, we freeze the weight so that this model can now ignore every other thing that it knows and focus on that exact aspect of what we want it to know, which is fine-tuned, now becomes fine-tuned data, right? Clinics actually do this too. Hospitals can actually do this too. Hospitals would feed the model data of patients from maybe ever since the hospital started, will feed it into the model, freeze every other part of the weight, and the model now becomes a specialized model that has been fine-tuned for the sole purpose of doing, right, giving it the very best thing. So the idea is that here is that if you remember when we were discussing, I think episode 4, and we had, I'm sorry about this stuff here. I don't know, this must be a browser issue, but I think you can still focus. So data, we say data is the soil of AI. And when we say data is the soil of AI, is that AI has a system. If this is artificial intelligence as a system, right? Remember that we said it is trained on data like all of the data on the internet, or at least a very large amount of it. So there's the math, there's the English, there's the science, there's the technology, there's the engineering, and there's, let's say, law, right? This is data as the soil. This is what is making your GPT. Now, if we want to go one level further, and we say, okay, we want this model to only know law, right? We want it to only know law. What we simply do is we just, freeze everything else here, and we keep law very active, right? So we raise law, we add more data to law, and then this model becomes extremely good at law. It becomes so good at law compared to a regular model because it wasn't trained on the amount of extra data that you're actually giving this new model, so that it is exceptionally good at law, right? So once again, always have that analogy in mind. I think it's the best. It's one of the most very brilliant things that happen in artificial intelligence, where if this did not happen, if you wanted to train your own model, you would have to get all the resources that ChatGPT used to build that system, maybe not as much as they did. And then you need to be able to feed your data into that system and then be able to extract it and give it out. And it would really be a lot of work, given that the talent is not that much, plus it's just very, very time consuming. So fine-tuning gave us the opportunity to just take that general doctor and teach him to be a brain surgeon and tell him to just quiet down every other thing that he knows so that he can actually create a system that works exceptionally. Now, where is all of this actually being used? I've given you examples in Copilot, I've given you examples in law, but next episode, we're going to actually talk about areas where systems fine-tuning systems are actually being used and they are making waves. And I'm going to go through examples with you so you'll be able to actually see that this thing works, right? It actually works and systems are actually made out of it. So next week on episode 17, we're talking in detail about the uses of fine-tuning model. But once again, I really hope this was very intuitive for you to understand what fine-tuning is, right? Fine-tuning is simply when we take the foundation model, which is like your ChatGPT, your Claude, right? Llama is also a foundation model. And when we say a foundation model, a model that was originally trained on large data all over the place, right? It knows about everything about everything, right? That's the model, right? We take that foundation model and then we train that same foundation model on specialized data, most times proprietary data, right? And this data is unique to one thing. So it might be cooking data, it might be law data, it might be space data. We just take it and we train the model on it. And then we say every other thing that you knew, right? Every other information you have, freeze it. It's not like you're forgetting it, just freeze it, keep it quiet, and then focus on the main thing that we want you to know, which is that exact data we are feeding you, including the new data we are adding, which is the specialized or proprietary data in this case. Add it to the original data that exists in the system, and then blow it up. Let that become your fine-tuned model, right? And then you can rename the model, obviously, because now you've taken it one step up. So that's how it works, right? And next week, we're going to be going deeper into real life cases of where these fine-tuned models actually work, and you'd actually see them like do amazing stuff. So I will see you next week on another episode of AI for Humans.